For more videos like this for Discrete 1, you can take a look at Sarai Studies, link is in the description box below.
Here we're told to show or prove that this compound proposition is equivalent to this compound proposition. The first step is to identify your longest, most complicated looking side. That's this one over here. And then the second step is to recognize that your goal is to get the side that you chose to look like the other side. So I'm going to start off with this side, which is not P and Q. And then I want to say, what is this equivalent to using one of these identities laws or known equivalences? Well, without even looking at the table kind of intuitively, I want you to understand that not just means opposite. And when you have an opposite outside of a compound proposition that's separated by an and or an or, you're just taking the opposite of every single thing, including the sign. Or in other words, you're just distributing in the not to everything. So not here would be not P. Opposite of and we know is or. Opposite of Q is just going to be the opposite of Q. So you distributed the not here, it went over here. You distributed the not here, we actually know what the opposite of and is, it's or. We distributed the not here, it went over here. We call this De Morgan's law. Now if you ever forgot, you would be looking for a not and an and. So here I see a not and an and, so you're going to be like, okay, what this is saying is that whatever is here is going to end up being the opposite. Whatever is here is going to end up being the opposite. So to color code for you, this is P, this is Q. So our answer is going to be the opposite. We're just adding a negation sign of P, which is this, and then the opposite sign, which is an or, the opposite right over here of whatever Q was, which was just Q. So hopefully you understand now that it's not just saying, oh, P is going to become the opposite of P. No, it's like whatever is in here. It could be a whole bunch of things. So in this case, it was not P. So since not P was here, this is going to result in not P, which is what we had, not P. Now remember, our goal is to get this to look like this side. This does not look like that yet. So we say, okay, what is that equivalent to? Well, there's this fancy thing called a double negation law, and it just says if you have two negations, they just cancel out. It's like math, a negative times a negative is a positive. So in this case, because I see two negations, opposite of the opposite is just going to be what it was at the beginning. They just cancel each other out. So here you're left with P, and then everything else drops down. And what's the law that we use? You have to write it down, the double negation law. And finally, we have our other side. We have P or not Q. So we're done. So we write a little square, and that's it. We showed that this compound proposition is equivalent to this compound proposition using known equivalences.